climate crisis as it pertains to water quality, oceanic pollution, ecological issues having to do with water. And this panel will be talking about green infrastructure and different resilience work happening in New York City. Our panelists are heavily involved in what's going on in our local waterways. So I wanted to bring the conversation for this event to a local perspective, and so I'm excited to chat more about this topic with you all. To introduce both of our panelists, we've got Vaughn. He's the head of product and outreach at Temboo. He helps people, communities, and organizations measure, share, and grow their sustainability and environmental efforts using sensors, open data, and community involvement. He helps partners use data, technology, and people to promote understanding and engagement with the environment for a greener world. Previously, he worked as an agent for the Wiley Agency, representing writers, managing intellectual property, and establishing a digital publishing business. He has an MBA in Innovation and Technology from NYU Stern and an AB in the Classics from Harvard. Welcome, Vaughn. Thanks for being here. And then we've got Kevin Dahms. He's a water resource engineer with a passion for incorporating ecological design into stormwater management, urban planning, and coastal resilience initiatives. Serving as Biohabitats Hudson River Bioregion team leader, Kevin oversees the firm's portfolio of work in New York, New Jersey, and Connecticut, which includes a diverse mix of habitat restoration and nature-based resilience design and implementation projects. Thank you for being here, Kevin. So to start off, I want to talk a little bit about, or just give the audience and everyone a little bit more context on what Temboo and Biohabitats do, and then if you want to speak to some of the current projects you guys are working on, and then we can dive into some further questions there. We can start with Vaughn.
Great, thank you, Claire. So I'll talk a little bit about what my company Temboo does. So Temboo is an environmental data platform, and it's really about bringing people, data, and technology together to both collect data and information about what's going on in the environment, specifically air quality, water quality, and green infrastructure performance, and using all of that data to basically bring communities and people together and help them learn about what's actually going on in the environment, in the local environment near them, and then being able to use that information to advocate and pursue change, whether it's through community efforts, whether it's through political efforts, whether it's through also just educating the community as well.
Could you speak a little louder, please?
Yeah, sure. Thank you. So Temboo is an environmental data platform that basically uses a wide variety of sensors, and we help a lot of different organizations, community organizations, nonprofit groups, environmental groups, state and local governments, basically collect environmental data using a wide variety of air quality sensors, water quality sensors, and soil sensors too, to look at green infrastructure performance. I think I can talk a little bit more about the specific projects, but that's all too.
Sure. Thanks. So Biohabitats is an ecological consulting firm. We have landscape architects, engineers, ecologists, environmental scientists on our team, and we specialize in conservation planning, ecological restoration, and regenerative design. So really thinking about how can we improve the ecological function and services of the landscapes, the cities, and where we work. We do everything from assessment and planning up through design and implementation, which is really exciting. We get to see projects go out to perhaps a degraded landscape or an impacted area, assess some of the issues that exist there, develop solutions to address those issues, whether it's climate change, stormwater runoff, or habitat degradation. And then we see those projects up through construction, so seeing those implementation projects. And so my background is in water resource engineering. I've worked with New York City DEP for a few years doing green infrastructure throughout the city. But since being at Biohabitats, I've been at Biohabitats for about 5 years. Been working on a number of projects from wetland restoration, living shorelines, and other coastal resilience measures, really throughout the city and throughout the region. So my office's projects are based in New Jersey, New York, and Connecticut. And it's been really exciting to see the range of work that's coming out. And so, like Vaughn mentioned, we work a lot with nonprofit organizations, some municipalities, and state agencies as well. So definitely some overlap. Vaughn and I were talking before, some overlap in the clients that we have, and even some of the sites that we've been working at.
Thank you both for giving some more context to the work you both are doing. So Vaughn, in our initial conversation, you spoke a little bit about, so what your technology provides is data that can really, provide greater transparency around, water quality, soil quality, air quality, and the communities that you're working within. I'm wondering if you could speak more to the role of community engagement, and you mentioned stewardship as well, generating, more energy around, stewarding, green infrastructure projects, and really how that can help provide longevity for the community that they're impacting.
Yeah, definitely. Thank you, Claire. So I think the best way to talk about this is to actually just go into a specific example of some work that we've done in the city, specifically in the Gowanus neighborhood in Brooklyn. This was a project wherein we were working with the Gowanus Canal Conservancy, and we wanted to look at street trees, the trees that you see on the sidewalk every day in every neighborhood in New York, and look at the street trees in terms of how they perform as green infrastructure. And so what that really means is, how well do these trees absorb water during rain events and retain that water and keep it out of the sewer system in the city? So New York's sewer system is mostly a combined sewer system, and what that means is that runoff from the street, from the street grates that you see, that goes into the same sewer system as when you flush your toilet or the drain in your house. They're not separated. And so what that means is that when it rains, there's so much water flowing through that combined system that the sewage plants basically don't have the capacity to treat all of that water together, and have to let it flow out into the waterways of the city, into the East River, into ultimately into the ocean. That's bad, and that's called a combined sewer overflow, or a CSO. And so a lot of what the efforts around green infrastructure are really about is keeping as much of the rainwater, the street water, out of the combined sewer system, so that you reduce the amount or the frequency of CSOs, so that you're not having to release all of this water that's full of untreated sewage, essentially, into the waterways. So what they were looking at, what they wanted to see is, how well do street trees help contribute to reducing CSOs. There's lots of different things that can, impact how well trees are doing in terms of water absorption. And it can be anything from, does the street tree bed have a tree guard that keeps people from walking on the tree bed? And when people walk on the tree bed, it compacts the soil of the tree bed, and you'll see puddles forming on top of the tree bed, so the water's not actually getting into the ground there. What you really want to do is promote as much water absorption and water retention in these tree beds at the same time. So to that end, we worked with Gowanus Canal Conservancy to install a number of soil moisture sensors in tree beds throughout the Gowanus neighborhood. And basically what these soil moisture sensors would tell you is they would, every 10 minutes collect the soil moisture readings from individual tree beds, transmit them in real time to the internet, so that we could look at it on our platform and see, both the current soil moisture readings and the historical readings. And basically, what you want to see during a rain event is the soil taking in as much rain as possible, and then after the rain event, you want it releasing that moisture as slowly as possible to basically get rid of the crush of water that's coming into the sewer system and triggering a combined sewer overflow. So what was really interesting about collecting this data to see which street trees would perform the best is, originally we were thinking, it's going to be a certain type of tree that does best, or a certain age of tree, some other factor like that, whether or not the tree has a street guard. But what we really ended up finding from looking at the data was that actually the trees that performed the best were the ones that were stewarded, that were actually taken care of by the neighborhood. And you could see that, both we would have some sense of which trees were already being stewarded because Kiwanis Conservancy runs a tree stewardship team of volunteers, and so there was some indication there. But you could also see which trees are being stewarded as well or taken care of actually from the soil moisture data itself, because you could see trees being watered when it wasn't raining. Because there's lots of people who will take care of the tree in front of their house, and they don't have to be part of some formal volunteer program. And what I think was most heartening about these results is, really seeing the impact of stewardship on the trees and how well they take in water, because stewardship is actually something that you can change quickly. You can't rip out all the trees in the neighborhood and plant new ones, or that would be infeasible, or you can't ask all the trees in the neighborhood to be 20 years older and take in more water. But you can, with a lot of effort and a lot of organizing, make sure that all the trees are much better taken care of, either through volunteer efforts or through working with the Parks Department, who's responsible for a lot of the street trees in New York City. And I think that was a really powerful finding, because not only did the data that we were helping GCC collect sort of help them learn what made the street trees perform better as green infrastructure, but it also gave another reward to the current existing volunteers and the existing community members who are engaged, and an impetus to get even more of them involved in sort of a great feedback loop there. And so I think that's a lot of what happens with helping collect this data. It's not always a data collection process, it's also a community engagement process, and by sharing this information with more people, it also ends up inspiring a lot of follow-on action in a virtuous cycle.
Very cool. Yeah, it's awesome to hear how it kind of creates that ripple effect of, affirmation that these, design decisions and nature-based solutions really do have that effect, and showcasing that to community members and then, organizations as it ripples out is very important. So Kevin, your work consists of, implementing ecological design and, dealing with stormwater treatment and management systems and, landscape restoration and ecological restoration. And I'm curious what your thoughts are on, the potentials for nature-based solutions and green infrastructure to really, be implemented at a higher scale in urban settings, and where you see that work, evolving to, in respect to, what your work currently
Sure, yeah, I think also want to just build off of the question about stewardship and what Vaughn was saying. Part of Biohabitats' mission, our mission is to restore the earth and inspire ecological stewardship, and the inspire ecological stewardship part of that is really important, because, as Vaughn was saying, stewardship is one of the most important things for how these nature-based solutions perform. And so when you're able to give data or have community members or organizations the ability to see how something is performing, or you can see that it is working, that really does inspire stewardship for them. So I think resources like that are really key to having these projects be successful. Nature-based solutions and ecological restoration in urban settings is certainly a little bit more challenging than other areas. I talk to folks who are out west, and they're like, "Oh, you're doing restoration in New York City. How are you doing that? And what are you even restoring?" Because they're working on these large landscapes. But I think when we look at New York City or places in New Jersey and Connecticut that have been developed and degraded for so long, I think there's so much potential there, where one of the key things is it's hard. You're not going to go back to what was there before colonization and industrial revolution and everything. You have to think about what are the processes that are happening right now, and how do we work within those systems and the current conditions to try and restore some ecological function. And so when we talk about scaling it up, it's first trying to conserve and protect high value habitat and high value systems that exist. But then how do you try and link them together and get the most out of those systems? And so identifying the areas where you can have the largest impact, whether that's, and I think we were talking about Jamaica Bay earlier, so thinking about Jamaica Bay, how can you really try and protect that habitat and enhance the ecological, the ecosystems that are out in Jamaica Bay. And then you're thinking about things like green infrastructure. I think it's trying to have a wider toolbox. It's not just bioswales that are, bioswales might not be appropriate everywhere. You have to think about different options in different settings. And so much of what we do is so site specific. We're like, oh, like this work here, and it's like going to depend on your soil conditions. It's going to depend on how tall the buildings are around, and how much water you're getting. And then you have to like monitor that. And I think the other piece of that is adaptive management. So thinking about how you change, whether it's the stewardship or maybe you change the plant palette over time to kind of adapt to what you're seeing and the field and getting from the monitoring that you're doing.
Actually, something you just mentioned, Kevin. So another question I had for both of you, but from your perspective as an engineer and dealing with ecological restoration, on the topic of how these projects assess like certain plants and greenery, and how those may absorb greater amounts of water, but also be able to withstand greater levels of salt or like other nutrients as they'll be brought in due to sea level rise and seawater. And I'm curious, from your perspective, how you consult or advise on those kinds of decisions that are being made by landscape architects or people involved in these kinds of waterfront projects, and how that kind of plays out, and also from your perspective what your opinion is on kind of what that process looks like.
Yeah. So we get that question a lot. How is this landscape going to change with sea level rise, or how are we planning? And something that's really important to consider when you're thinking about restoration is you're planning and designing the project to function the day it's built, but then also over time. And so some of the big considerations there is what's the land use adjacent to your restoration project or your marsh. So if you have a salt marsh, which again has specific vegetation that is has evolved to exist and survive within saltwater conditions with certain tidal inundation, over time that vegetation is going to move upland because the upland is going to be getting flooded more. And so not having paved roads or buildings right next to your marsh is going to allow that vegetation to move upland. And so I think it's a land use decision as well as a design decision. And so just making sure that there's not those barriers there. You could even think of that with things like aquatic connectivity and fish passage, right? Like when you're designing a road crossing, whether it's a bridge or a culvert, if you're going to go in and do a new design, make it so that fish can get through there so they can go upstream and migrate. And so I think just thinking about those infrastructure decisions to be friendlier to the fauna and the flora that exist in the ecosystem is really important.
Yeah, I think one of in terms of making one of these spaces last and work from day one to, many years from now, I think one of the things that I've learned from working with a number of different groups and organizations that are focused on these waterfront areas is, I tend to think about it, from a very how are you gonna design the environment, and how are you gonna perfect all of that. I think what I've learned a lot from the organizations that I work with is how much of the community part of it is really important, and not just in like a feel-good way, but also part of making these places accessible to people. Not only is it benefit in and of itself, but then you're also creating a constituency of people who care about that space and who will then help take care of it or put pressure on other people to take care of it. And I think that's something that, I didn't really realize how important that was. It's not about necessarily, restoring this place to some perfect condition, which is not really doesn't even achievable now. Like you're not going to erase the Industrial Revolution, like you said, but like even just giving people access to it, like the sooner the better, in some ways will create momentum for changing and like pulling it through all the next steps in terms of reclaiming that area.
Thank you. I also just wanted to touch on, sea level rise and dealing with flood mitigation and risks in terms of that, and the conversation of like where to build that line of adaptation. So essentially, like where the water will come up to if you're designing for a waterfront, and it's a question sometimes like how landscape architects and designers can really build this, and it can shift based on how the space is being used, if it's being accessed by people, and if it's a park, and it's very, very difficult to actually build in water. So like it's highly permitted and it's nearly impossible. There is a landscape architecture firm that is successfully actually closing a huge construction project in Staten Island that's building this large breakwater front. But it's extremely difficult to build in water. And so in terms of, dealing with flood mitigation, it's always having to take place on land. And I'm just curious if you guys have, experienced a variety of conversations around, those kinds of design approaches, but also like when you're coming up against, different policies or regulations in terms of implementing, certain projects that, could benefit the community in a myriad of ways. I'm curious what your thoughts are on, government perspective and kind of where policy comes in.
Yeah, so I think it's a good question. We just did a feasibility study for a living shoreline project in Norwalk, Connecticut, and the community was really interested in building out this marsh out into the harbor. And to your point, Claire, that's a much more difficult project to permit, also difficult to construct. Things might settle and sink into that sediment. And so the feasibility study basically looked at, okay, building out versus building in, what are the cost differentials? And so I think it really depends on your project's goals and the objectives, and also what kind of budget do you have. I think also when you think about sustainability or like resilience and like the longevity of the project, is building out into the water that's going to be where your tide's coming up higher and higher. Is that smarter, or is it just adapting your land use within your park so that it can be flooded? Maybe it's a more natural system and it's not being mowed lawn for fields anymore. That's a much softer and easier approach. And then I think things like living breakwaters, things like oyster restoration, green infrastructure, we do a lot of natural stormwater conveyance projects. Some of these are new strategies that engineers, civil engineers just aren't as familiar or comfortable with, and so it just takes education. And I think pilot projects are really like the best way to get folks to understand how to get data and getting data from those pilot projects is really important to show, hey, this works just as well as your concrete line channel or your riprap shoreline, because that's how the regulators are going to ultimately be able to approve these projects. So I think it's getting those projects in and then monitoring them and showing that they perform well.
Yeah, and I'll just say to your question, Claire, like the nature of my work and what we do, we kind of like less involved with the permitting and government regulation aspect of it, but what we are involved with is basically where you left off with the actual helping organizations like collect real data about the performance, particularly of green infrastructure solutions, because there is a lot of civil engineers and that that's just not part of their necessarily their toolkit or what they have experience with, and a lot of what's known about green infrastructure is often like modeled in terms of how the performance will be, and there's not as much real data on how it's performing in real time. And I think part of what we're doing is like kind of brick by brick, like building that record of information and performance modeling and showing how these things can work, and you're sort of building that argument for green infrastructure solutions. Yeah.
Data provides more information and enables progress in new ways. I want to open it up to you all if you have any questions that are coming to mind.
I have a question.
Yeah.
In terms of related to the data and information, like obviously you have to perform experiments, right? Scientific method, I'm assuming you have the idea, you approach it with, your hypothesis, and then obviously you're probably doing these experiments on a much more minute scale. Obviously it's gotta be cost efficient as well. You're not gonna go out and just, test the marsh or test the sediment and then, go off of that. So would you create these models in-house or like within the lab? How do you go about in terms of obtaining this data? How do you go about that process?
Sorry, just to repeat for everyone, the question was around how they go about obtaining certain data in terms of their scientific method and kind of experimentation process.
Yeah, I can go first, sure. So first, we mostly, as Vaughn said, we do a lot of models to start. So we're in design. There's different software out there you can do models and look at how well, say, a rain garden is going to perform, or in a coastal system. You can model breakwaters, you can model shorelines, and see how well they're going to damping waves, or things like that. So we do it in a model first, and then we rely on performance monitoring on the project after. So you look, and you actually do go out into the field. You actually build it, and you say, okay, this shoreline has shifted this much after 3 years. This vegetation survived, and this hasn't, and you build off of that. And so I think that's like how those larger scale projects are done. You base it on a model that is then vetted, has been calibrated through field monitoring. But then I think for some creative and innovative approaches, we do sometimes try to do what's a designed experiment where you might actually incorporate into your implementation different strategies. So if you're looking at bottom habitat enhancement for oysters or benthic organisms or fish, maybe you try a few different approaches like reef balls here, scabions with shell here, and then you go out and you monitor that to see which one's performing best, and then you can use that to scale up your design in other projects. So trying to build in that experimental design into your design when the budget and the project partner allows. We're often working for clients who are I just want my shoreline to not erode, and they're not necessarily interested in trying out different methods, but it's trying to find those opportunities to do those
And then in
experiments.
terms of budget, obviously you're receiving budget from investors who are backing sustainability or carbon possibly.
Hey, I wish we were receiving money from investors. We're receiving money from government grants. Or municipal budgets. So the budgets are pretty small. I think for some of the more creative approaches, there is money being invested. But yeah, it's often taxpayer dollars, and so we often have to justify what we're doing for that. So, and that's a limiting factor. But fortunately, there is a lot of interest in money now going into this type of work.
Yeah, that was a secondary question.
Yeah.
Where's the funding?
Yes. Yeah. So a lot of our clients are nonprofits or government agencies, and a lot of our projects are grant funded or coming out of budgets from a government for flood mitigation and things like that.
Thank you.
Yeah, and I would say it's very hard, to design a scientific experiment because all these things are in the real world, so you kind of can't.
That was my
But-
thought. It's how do you
so
actually model that?
And then there's the reality of, the budget constraints and the like. So for example, when I was talking about the project we did with the monitoring of the street tree beds, there are hundreds of them in the Gowanus neighborhood. It's not feasible from any perspective, a budget, time or manpower perspective to actually put sensors in each individual tree bed. So, we do the best we can. We probably did around 10 to 20. And you are as strategic as possible about trying to account for as many variables among those beds, and maybe occasionally moving some of those sensors to different beds to get more data there. And really, it's a lot too of a kind of a collaborative approach where often when we're trying to do that sampling, it's kind of us talking with the client that we're working with about what do we think are all the variables that matter. Time to do that. And there's other people I'll just talk to from what I've learned from other projects or just other people I know who I can rely on, and you just sort of do a sanity check on the project to see if you've talked to several knowledgeable people, like does this seem we're accounting for enough given the constraints. And the thing is that sadly, like often like, none of this data is being collected, so you know, not to say, you know, so you want to make sure it's good data, but it's also like the best you can get, basically.
The best is data.
Yeah.
Compared to
And exactly.
compared to any other data, yeah. Okay, thank you.
Thank you for that question, Micah. Does anybody else have a question? We probably have time for, one or two more.
Thank you so much for sharing. It's very interesting to hear about the progress of MBS. I'm wondering, how would you compare, say, the impact and effectiveness of green infrastructure with nature-based solutions? Is there like a set of metrics that you use to compare against both? And would it be true to say that usually nature-based solutions would take longer time to realize their benefits compared with maybe erecting a seawall versus like building a new sort of marsh or constructed wetland or even mangroves to achieve some of the similar impacts? Thank you.
I'll speak. So I haven't been involved too much with my work in really comparing them as much. My opinion is that we need both systems in place, and there's often times where they're not directly comparable just because like space constraints, particularly if you're talking about an urban environment like New York. Like there's a lot of things that you can do with green infrastructure sort of in the seams of the streetscape, like street trees or urban shorelines, things where you wouldn't be able to build maybe necessarily a large piece of gray infrastructure. So I think it's often like we need both, and they're suited to different problems in different areas, but I'm sure you can speak more about it.
Yeah, so there are certainly resources out there that do that one-to-one comparison. I think to Vaughn's point, like, we need both. But when you talk about comparing a gray infrastructure to a nature-based solution, I don't think it necessarily requires more time. It might depend again on the context. And again, I think a simple example is a rain garden or something like for stormwater green infrastructure. That's a pretty we know how much water a rain garden is going to be managing generally, the way it's designed, and you can compare that to X number of rain gardens is going to manage this much runoff and reduce your CSOs by this much, compared to say a tank or something like that. Similarly, when you think about maybe some there's a lot of research out there on how effective marshes are at dampening wave energy or storm surge, things like that. It's limited compared to a seawall for certain size storms, but it is effective. And I think, again, especially if you have an existing marsh, conserving and protecting that marsh is going to be a more cost-effective solution than building gray infrastructure. So I think it's just balancing the site constraints with your budget and what the goals of the project are. I think some nature-based solutions do take time to maybe mature, but I do think that a lot of them have an impact immediately, especially when you think about the oysters or any reef structure, because it's not just the oysters themselves, you're also creating habitat and like refuge for fish and everything, so that's providing habitat benefits. But those structures can also provide wave dampening benefits.
Over here.
So I don't think that New York was designed with sustainability in mind, and so I don't think the biggest city in the world are like. So what is one project that you know of that the city is developing to create or shape or reframe or redesign the existing infrastructure for the future, right? Both from a design perspective and an perspective.
Thank you for that question.
I can take it if you want.
I mean, I don't know all the big plans that New York City has, but I mean, I think something just as simple as expanding all of the rain gardens, because there is like a lot of space for that, and that is also just distributing the green infrastructure through like a lot of different areas, and also it's also bringing more green space, and also there's a visibility element of it too, where it's just more people see it. And I think there's a lot of things like that doesn't sound too like earth-shattering, but there's just so much paved space in the city that could be either removed or replaced with permeable pavement and the like, and like you have such a huge area that you're already working with, that even just like each percentage change in it will have like a huge effect, and it can touch as many neighborhoods as possible, is what I would say.
Yeah, one project that comes to mind, we were involved in the concept stage, but not more recently, but they just starting construction, is the Tibbetts Brook daylighting project in the Bronx. So that's it's a stream that was put in underground into a pipe, and that was contributing to the combined sewer overflows that Vaughn mentioned earlier, because it was basically just getting mixed in with everything, right? So all that, whenever that stream was flowing, it was going to contribute to that issue. So the city is now daylighting that stream and bringing it to the surface and making it stream again. And I think we're starting to see, like when Claire asked about scaling up, like we're seeing projects like that that are having this much bigger benefit. But that's a big benefit for the city in terms of their CSO reduction and water quality improvements. And so thinking about large projects like that, I think is really fascinating. You know, there are other underground streams in the city. Can we daylight them? Whether it's a CSO mitigation project or it's a habitat improvement project, you know, getting flowing water for the city again. And thinking about that. So I think that's an example of that.
Do you remember the low line?
Sorry?
The low
The low line.
Do you remember? Do you guys know where so this is the high line, right?
Uh-huh.
And then there was the project that they were bringing the sun underground, where they build gardens under the caves of New York. New York? No. Okay.
Is that here? Where was it, in the Bronx or?
No, it was just down. So when you go to the Williamsburg Bridge, before the Williamsburg Bridge, where they did the new mall, that's an empty, gigantic space, because was underground is like 70,000 or 80,000 feet for the carriers and the horses. So it was a big space, and they were building an underground garden by bringing the light to the sun through the lens into what's called the low line. The guy that was the head of the project had a personal gigantic drama and couldn't develop it, but that was one major beautiful project.
Yeah, I think it's making use of those spaces because we are so limited by real estate. And I mean, again, things like the High Line, the prime example where you can have that greenery in such a dense environment. And I do want to emphasize what Vaughn said about impervious surfaces. So any hard surfaces, there's a lot of opportunity to get rid of them and turn them into green space or permeable surfaces.
Yeah, certainly. As much as absorbent as the built environment can be is ideal. Okay, to close it off, I just want to ask each of you what your definition of resilience is, because I think that's a word that, we're using it a lot, and, in terms of building it and, building systems of resilience, and whether it's social, climate, ecological, economic, even, how it comes up in each of your work, or just what you both think. I'm curious what it is.
Sure, I'll take that. I mean, I think there's a lot of something with a lot of different strategies, whether they're engineering strategies or the whatnot, but I think what really counts is, connecting people to each other and to their environment, and that's really what can create, at least in environmental terms, a resilient community or a resilient city. Obviously, there's other ways to connect people together even more to make them resilient to all sorts of hardships.
Yeah, I don't know definition-wise, but I think what we like to think about is like taking a process-based approach, so understanding what are the drivers that are causing what you're trying to be resilient to, or what the solution you're looking for, and understanding those processes, and setting the system up for a trajectory of success, right? So they can continue to function. It's not just one fixed structural measure, and that goes with social systems as well. What's the community's relationship with the space, and are there people who are going to take care of it? How are they going to use it? You could create a nice meadow, but if people are going to go on and play soccer on it, it's going to be trampled. It's not going to be a meadow anymore. So thinking about that really holistically, and what kind of system and context is the project existing in, and trying to design a system that uses and works within those processes.
Okay, I'm gonna close it out. That was wonderful. Thank you, Vaughn. Thank you, Kevin. Thank you all for being here and being a part of this. I hope you all, have a little bit more information on what projects are currently going on in New York City in terms of, utilizing nature-based solutions, implementing green infrastructure, and that, with more data, there's more, room for progress and on, on a policy end and with different organizations. So, yeah, it's a big team effort. So I'm really glad you guys can both speak a little bit to your work. So you were all here.